Sir, Dr. Piyush, sir, have you joined now, sir?
Yes, can you hear me?
Yeah, yes, sir. Yes, sir.
Okay, good.
Sorry,
Yeah.
Sir, with your permission, can we start, sir?
Yeah, we can start.
Yeah, okay, sir. Thank you, sir. A very good evening to all the respected dignitaries, distinguished speakers, and dear participants. I am Dr. Qasim on behalf of Vishnu Institute of Technology, Bhimavaram. Welcome you all to the day 2 of our FDP, sponsored by AICT Atal Academy, New Delhi. After an inspiring inaugural and highly engaging sessions on electric vehicle and solar PV systems and power converters for microgrids by our esteemed chief guest, Dr. Mukesh sir from IIT Roorkee and Dr. D. Ravindra sir from MNIT Allahabad, we continue our journey into the core of energy conversion technologies. Today's session focuses on energy, climate, and sustainability policy by the expert, Dr. Piyush Verma sir, Senior Fellow, Energy and Climate Policy Lead, from ORF America. So it gives me a great pleasure to introduce our first speaker of the day, Dr. Piyush Verma sir. He is a senior fellow at the Observer Research Foundation, ORF America, where he leads the organization's work on energy and climate policy. His research focuses on the intersection of technology, economics, governance, and geopolitics, advanced solutions for a just and sustainable global energy transition. Before joining ORF America, Dr. Verma served as Chief Technical Advisor, Sustainable Energy at the UNDP SOMA multi-country office, supporting energy transition initiatives across the Pacific region. He also worked as Senior Advisor, Energy Governance at UNDP New York, leading just energy transition programs across more than 170 countries. He has contributed to national energy and climate policies in India, New Zealand, Ireland, the United States, Vanuatu, and NE, and chaired the Joint Task Force on Digitalization in Energy at the United Nations Economic Commission for Europe, UNECE, Geneva, in the year 2021 and 22. A global future energy leader, World Energy Council London, Dr. Verma has published over 80 plus articles and policy reports in leading international outlets, including the Times of India, Irish Times, RT Ireland, and the Sunday Times UK. He has spoken at high-level global conferences and intergovernmental platforms across 45 plus countries. Dr. Verma has been honored with the Gold Level Leadership and Service Award from the University of Auckland in the year 2018 and the Young Achiever Alumnus Award from the National Institute of Technology, Jamshedpur in the year 2024. He is also a senior member of IEEE USA. He holds a PhD in Energy Technology and Policy from University of Auckland, New Zealand, an MPA as an Edward S. Mason Fellow from the Harvard Kennedy School of Government, a Master's in Power System Engineering, and a Bachelor's in Electrical Engineering from India. So, with over 15 years of experience in energy policy, sustainability, and global environmental governance, Dr. Verma has been contributing extensively to shaping policy frameworks for sustainable development and climatic action. Today, he will deliver a talk on energy, climate, and sustainability policy, offering deep insights into how renewable energy, public policy, and sustainable development intersect in shaping our energy future. Thank you very much for accepting our invitation, sir. It's a hearty welcome to you, sir. It's a grand welcome for our FDP. Now, I request Dr. Piyush Verma, sir, to address the gathering. Over to you, sir. And thank you very much, sir.
Great. Thank you very much, Kasireddy. And thanks again for the invitation. Pleasure to be here at the Vision Institute. And of course, I'm looking forward a conversation, not just a presentation from my side, but a more kind of active participation. And with that, I would very much appreciate if I can talk to the faces on the screen. So if you feel comfortable, please open your camera, come on the screen, so that we can have a more lively conversation rather than just me talking. I would very much appreciate that. It doesn't look good just talking to the black kind of the boxes here. So let me share my screen, and then I'll start center mod. Okay. Can you see my screen now? No?
No, sir.
No, sir.
I think it is asking, we need permission to share your screen.
Yeah, sure, sir. We'll be making you as a presenter.
Yeah.
Sir, you are presenter, sir. You can present, sir. Just try
Okay.
it one more time, sir.
Let me presenter. Is it coming now?
No, sir. I mean,
Still.
are you pressing and share with screen, sir, not window, sir?
That's what I'm trying to. It still says
Sir, 1 second, sir. I will make you attendee and again make you as a presenter, sir. Just a second, sir.
yeah.
Sir, now check it, sir.
Somehow it still says we need permission. Shall I share my slides maybe? And then you can share the screen from that side.
No issue, sir. No issue. Kasireddy sir, I have removed him, made him as an attendee. So Piyush Verma sir will be presenter.
It still says like we need permission.
Maybe the spotlight. Maybe I'll stop spotlighting, sir. So now just try it, sir.
Yeah, let me. No, it's still not coming.
So now please please check, sir.
Yeah, when I'm doing like sharing, it says it needs permission.
Permission. Just a second, sir. There is no change in the.
So from our side, we
Seems
just
okay?
made you presenter. Maybe
Okay.
some technical issue will be there. So as you said, sir, please share the PPT, sir, so that we'll be sharing from our side, sir.
Yeah, maybe I think that would be better because I don't know
Yes,
why
sir.
it's asking for permission. So I've just sent over email. Can you just check?
Mail. Sir, to which mail ID, sir? Is it Kasirati, sir?
Yeah,
Kasirati
your
or-
email. Yeah, with the email with the invitation you sent.
Okay, sir. We have received it, sir. Just 1 minute, sir.
Okay. Okay, I think, yeah, I can see now.
Yeah, okay, sir.
Okay, yeah, so sorry for the hassle. Yeah, let's start. If you can do it, maybe the SharePoint, the PowerPoint mod, the full screen, I think that'd be good. The first one, the previous slide. Okay, yeah, so it always happens, some when you want to start. So let me start here. And as I said, I don't see anyone on the screen. If you can come on the screen, if you're comfortable, it would be great to make it lively conversation. So I would really appreciate that. Feel free to stop me if you want to stop anywhere else, but I'm also happy to take the questions at the end. To start with, I have put a slide here, in terms of, I would like to start with some of the challenges that we are facing in the world. We are going to talk about the policy solutions, right? The title of the talk is Climate, Energy, and Sustainability Policy. And in terms of the policy challenge at the global level that we are facing, there are so many policy challenges, but climate change is one of the most complex challenges that we are facing today. And in terms of climate change challenge that we talk about, what is actually happening, right? Climate change, is a word that is being used frequently, but what are the real impacts of climate change that we are seeing? So in terms of, for example, I have put a couple of pictures here. If you see the first picture, where we talk about the global temperature compared to late 19th century. And the picture here, the graph here, it shows that the last 10 years has been the hottest year on record in the history of the world, history of this planet. So that is like the extreme heat that we are seeing in the world is one of the most negative impact, we are seeing because of the fossil fuels that we have been burning for centuries. Because of the extreme heat, if you see the right top picture, there is wildfire happening in many parts of the world. Here in the US, in California, you might have heard that, there are very frequent wildfires. Then if you see, the other picture, there are a lot of cyclones and there are a lot of floods and there are the intensity and the frequency both have increased. Then if you see, this is another picture from Delhi, right? Where you already might be hearing the news, what's happening in Delhi, right? In terms of air pollution and how people are suffering, with the so many asthma and, so many other kind of breathing issues. And several people are getting hospitalized, more frequently. So these are the kind of real challenges of climate change that we are facing in the world, right? If you go to next slide. So I wanted to put this, I wanted to start this with the challenge, what kind of challenge we are facing in the world, okay? Because I was told that, there are all the faculties here, you are all kind of lecturers and senior lecturers, associate professors. You might be kind of doing a lot of research. You might be doing a lot of teaching on the subject. But kind of what is important really is to understand that the work that you are doing, either you are teaching or you are researching, you are sitting in a context, right? You are sitting in a society. You are sitting as part of an economic context as well, right? So the challenge here is to solve the real challenge, right? We want to make some contributions to the society. Okay, and here we are talking about one challenge, the climate change challenge, and the impact that we are seeing, how many millions of people are impacted. So how you can contribute, from your role, from your kind of research profile that you have, from your teaching profile, how you can contribute to that kind of the challenge of the society, of the economy, of the country, and maybe not just thinking at the national level. So many challenges are also at the very much kind of local level, state level, right? So how do you bring all this kind of different perspective into your work? So I thought to talk about, I think there was a kind introduction, but I think I wanted to tell this, a brief about kind of my journey, because it is important to understand that how, your role, as an engineer. I started my career as an engineer. I was also the first 2 years, of my journey, of my career, I was lecturing electrical engineering. I was a lecturer in a university in Dehradun. So, I started from there, but slowly, as I understood the challenges, of our society is facing, of our, the needs of the policy system, the needs of the government, the needs of the country. I started kind of that I need to maybe learn, different disciplines, different sectors, different stakeholders, how they work together. And I think that was the kind of the passion that brought me here, working kind of internationally, looking at the challenge. It's the same challenge, it's the same energy and climate challenge that you are trying to solve, and then I was trying to solve, 20 years ago, as a lecturer in electrical engineering department, right? But what I did not have at that time, this global perspective, this understanding of how our work that we are doing in the university, how that connects to the broader, the challenge and then solution that we need to develop, right? So uh, that's what kind of I wanted to make that connection. And I think with this journey, as I'm saying, like, I started as an electrical engineer, lecturing. I moved into industry. I worked at Tata Steel in Jamshedpur, and then slowly I moved into the policy. So I worked for the, for example, this the organization, the Bureau of Energy Efficiency, Government of India, where, I started looking at, from the policy angle, and especially at the national policy angle, like what are the issues, when it comes to energy, and especially energy efficiency and energy conservation was a big topic at that time, right? Still, we are kind of working on those kind of, aspects. But like, how do you connect those dots? So what I'm trying to say here, that, you are sitting in your own kind of, department and discipline, and very focused research of electrical engineering, but you need to also think about at the big picture level, right? How you can make a contribution to the society, because the research that you are doing, if it is not helpful for the society, if it is not helpful for the country, then, there is of no use. Publishing a paper is just a means, right? Or if you are teaching, how you can the student that you are teaching, it's they are the future of the nation, right? They need to create this, our next generation society, next generation country, right? So how we help them connect that at the very micro level stuff, to the big picture issues and the big picture solution that we are trying to develop. So I think that's what I wanted to convey that here. Okay, next slide. And that's where it comes. Okay, so I have written here the interdisciplinary solution. Okay, as I said, my own journey, I have moved from, engineering to looking at the, I don't look just look at the technological angle, right? I did my, engineering, like bachelor electrical engineering, master's in power system engineering core. But the world kind of, we are in, the challenges that we are facing, especially the climate change challenge, it's an interdisciplinary challenge. It cannot be solved by just engineers or economists or humanitarian or social scientist, right? It is asking for interdisciplinary solutions. And to bring interdisciplinary solutions, you need to think interdisciplinary, you need to collaborate interdisciplinary, right? You need to engage interdisciplinary. Sometimes you need to talk, with other department people. Sometimes you need to collaborate with other department people, and I'm not just saying between engineering, think about maybe collaborating with an engineer and, with someone, who has finance expertise, someone who has, material science expertise, right? Someone who has, maybe social science expertise, right? Because the solution that you are developing as a researcher, it has to sit in the context. It has to sit in the economy. It has to sit in the society, right? So how do you think about that, and how you can contribute to this, the very kind of local challenge, or the national challenge or the global challenge? So I think it is very, very important that we think from an interdisciplinary angle. Okay, next slide. And that's where the thing is, why our climate solutions are so stuck, right? Why we are like not able to solve the challenge. Okay, if you take an example, the COVID-19 that came, right? And if you look at the COVID-19, those kind of 3 years period, how, we solved the challenge, how, in that very limited time, 3 years is a very short time, right? We made breakthrough innovations. We brought like, breakthrough vaccines, we brought like, the production, the pilot, the testing, the scale, we produced like billions and billions of vaccine, and, and the vaccine was provided all over the world, every parts of the world, like every country got that, right? Uh, the whole kind of learning from the COVID-19 journey was an interdisciplinary approach. Every sector of the economy started, working towards developing the solution. And that's what is kind of, we have started looking at the climate solutions, from that angle, but it is just an start, right? I think to really, and we don't have much time, in terms of, the thing that we are talking about, like how much we need to, how much time we have to address the challenge of climate change. It's like many countries have this like 2050 goals, for example, right? Net zero 2050 goals. In India, we have net zero 2070 goals. So the consequences, if we don't do that, the consequences are going to be serious, right? But the solutions are getting stuck because many times we work in our own silos with our own discipline, with a very closed set of stakeholders, right? So how do you kind of broaden that, perspective? How do you, as an engineer, as a technologist, how do we think about the technology that, how the technology can be more affordable, right? Because the cost is a big factor. If you take your research, or if you take your product, to the policymakers, the first thing policymakers look at from the economics angle, right? Is that solution, economically effective, right? How do you think about environmentally sustainable? The solution that you are developing, the research that you are doing, is that environmentally sustainable? It should not harm the environment, right? Then you think about maybe from a geopolitical angle. Geopolitical means, right, is like, for example, if you are if you are developing, maybe, for example, in our country, in India, right, we have this solar panels, boom going on at the moment. We are developing kind of multiple policies, and we are the solar scale is at a completely different level in India, right? But think about like what the materials are needed for those solar panels, right? And where those materials come from, right? We are still dependent on many other countries, for procuring those materials that we need to build the solar panels. So what, it's a geopolitical, we call it, it's a dependency on other countries, right? So from your research, what you can do, for making our own kind of, the value chain that we need, the raw materials that we need for renewable energy technologies, from our own countries, how it can be developed, what are the new research needed, right? So thinking from those angles, economics, thinking from the geopolitics that I was talking about, thinking from the environmental perspective, right? All these are really important. So you do your research, but at the same time, we need to have these kind of perspectives in mind when you are also teaching students. I'm sure like a lot of you are also like doing both research and teaching. So in the teaching as well, how do you give students this bigger perspective, not just a particular technology, but this bigger perspective about that technology sits in the economy, the technology sits in the society, the policymakers have to make policies, right? So all these dots need to be connected, and so that everybody can think about, from a national, perspective, that we are contributing, whatever the research or teaching you are doing, you are contributing for the society, you are contributing for the country, right? We have our national vision, right? 2047, for example, the Viksit Bharat, right? How you can contribute to Viksit Bharat from your own research and teaching. So you need to start kind of think about from that angle, and that we need to give it to our next generation as well. Okay, next slide. So for example, I was talking about, the interdisciplinary approach, right? And this is just one example how we work at ORF America. Okay, so ORF America, it's a kind of think tank. I did not introduce earlier, but ORF America is a think tank, that look at on different topics, and looks at really kind of multidisciplinary approach. Okay, so we do a lot of research as well. We do a lot of, dialogues as well. So I'll talk about that. But how we look at, for example, in our, I lead the energy and climate program at ORF America. Half of my job is to look at the US-India relations. So how United States and India can collaborate more closely on energy policies, energy transition, or the other different parts of the energy sector, right? And then where this kind of collaboration opportunities that can happen. So how we look at those topics, so as I said, like US India, and then we also look at, in my team, the global north countries and global south countries. So maybe you can say like developed countries and developing countries, right? The developed countries like Europe, US, Japan, like other South Korea, other these kind of developed countries, and how they should collaborate with developing countries like in Southeast Asia or Africa, or Pacific countries, small countries, right? So those kind of collaborations. So we look at these kind of perspective. But when we look at these collaborations making contribution to the world at the global level, we look at from the cross-cutting themes. Okay, and cross-cutting themes, for example, I have put like 4 cross-cutting themes here. Governance, for example. Okay, so when we say governance, it's policy. For example, when we say policy is one piece of the governance. Okay, one part of the governance. So for example, as an engineer, as a technologist, as an academic, when you are working, on maybe any particular kind of research, any solar for example, solar kind of, you are developing some advanced solar module in your research, right? That advanced solar module that you are developing, it will contribute to that solar panel, then solar panel, has to come kind of supported by the solar policy, right? And then solar policy has to be made by some institution. For example, in India, we have Ministry of New and Renewable Energy, right? So we are talking about, see the how a small kind of research, that you are doing, it's a big area for you, but how it is connected to the really more bigger picture, the more bigger change, on the value chain that it will create, right? So institutions, policies, regulations, right? All these matter. In India, for example, when we are doing any, for example, new solar policy, right? There has to be also a stakeholder engagement. For example, the policy is announced, and then there are multiple stakeholders, multiple companies and non-profit companies and universities, they do their contribution, like, okay, no, this policy should not be like this policy should be like this, right? So that we call it like a stakeholder engagement, right? Policies, when the policies put in place, when the policies are introduced, there has to be someone kind of coordinating that policy. Someone, as some agency need to make sure that the policies are, effectively implemented, right? So all this part of the governance. So we also look at from that angle. We look at from the diplomacy angle. Okay. So the diplomacy, for example, is looking at, like, for example, I was saying US and India collaboration, right? So how US and India can collaborate, more effectively on energy. So when we think about from the diplomacy angle, we think about, okay, what is the strength of India? Okay. What is the strength of United States? Okay. What are the gaps that India can fill in the United States energy journey? And what are the gaps that US can fill in India's energy journey? Right? So you think about from these different angles, and then you try to bring like strength and weaknesses of different countries, and then make this complementarity to maybe bring two countries together, maybe bring like three or four countries together. Okay. So you develop this kind of collaboration between countries. For example, what I'm suggesting for you in your kind of research, to do interdisciplinary, right? Because everybody has certain strength. The different disciplines bring different approach. So similarly, we are trying to do at the international level. Finance, right? This is another very, very, very important aspect, right? I was talking about the economics. The policies has to be, effective. The technology has to be kind of economically effective, right? Economically viable. So how do you think about that, right? Similarly, at the kind of big picture level, we think about like, okay, if we are going to do this, where is the money going to flow, right? How much borrowing the money will cost, right? Is it sustainable, right? At what interest rate? So all this like big picture thinking comes into that. So I'm trying to make the connection, the kind of research and teaching that you are doing, think about like how that is connected with all these cross-cutting themes. And technology, of course, you are already working, right? So what are the emerging climate technologies? What are the low emission technology, for example? Another example, if you can take, like, maybe what are the new technologies coming, like hydrogen is coming, right? The new electric cars are coming. How we can make it more efficient, right? How we can make it like zero emission technology, zero emission electric vehicle, how we can make zero emission maybe metro system, zero emission rail system, right? So all this comes from research. So how do you kind of start kind of thinking about that? And then also the digital innovations, like all the new digital technologies are coming, like how digital technologies can help in the energy transition, right? In the whole energy journey and the whole energy sector that we are kind of operating with, what are the contribution that digital technologies can make to to make the energy system more efficient and more effective. Next slide. So again, it is coming back to this kind of same approach, the idea of whole, what I was trying to say, that, combine expertise from different fields. I think, having worked in, I would say 5, 6 different countries, and having worked in, also traveled over 50 countries, and, engaging with multiple organizations, multiple universities and researchers. I think, there are a lot of opportunity for us, in our home country, in India, to do more kind of interdisciplinary research. This is one area that I would kind of strongly recommend to think about, not just thinking about from an engineering perspective, but always think about, how that technology, it will be implemented in the society and economy, right? So who are the key kind of collaborators that you can ask, right? For example, if you are developing a technology, ask, someone in the, who is a social scientist, like, what do you think about this technology? Right. In terms of like, what are the challenge that society can face when you implement this technology? For example, when you are putting a wind turbine, I'll give you a kind of anecdote. When I was working in Ireland, the wind turbine was kind of, getting kind of popular, and there was a whole group of kind of lobby of people who were saying that we don't want wind turbines in our country, because when you look at wind turbine, it makes dizzy, right? It doesn't look good. It kills bird, right? So there are a lot of those kind of aspect as well, right? You might not have heard about, like, wind turbine has always been like, good in many countries, but some of the people in some of the countries have been opposing as well, right? So it's important to get their perspective, like what they're thinking about it, and how, through your own research, what you can do about it, right? Similarly, if the finance is an issue, if the economics is an issue, how you can make the wind turbine blades maybe more cost effective, what kind of material you can use to make the blades, right? So that it can generate more power, but at the low cost, right? So all these angles that you can think about. And that's where the whole kind of interdisciplinary idea is coming in. Okay, next slide. So I wanted to put this slide, just to show you kind of how we are looking at it. For example, I talked about the cross-cutting themes. We look at from the technology, diplomacy. We look at from the finance, governance, all these different angle. But in terms of like kind of our, the focus area, okay, where we do our research, what are the kind of 5 big issues, that we are trying to solve in the world. Okay, so if you see the inner circle, the colored one, you see there, maybe one of the topic is heavy industry decarbonization. Okay, this is a very, very complex challenge at the moment that energy experts at the global level are trying to solve. Okay, heavy industry decarbonization is called, for example, steel sector, okay, or aluminum sector, or chemical sector, right? These are the sector that consume lot of energy. Okay, lot of energy coming from fossil fuel. Okay, so for example, coal, oil, gas is the fossil fuel, right? So lot of energy coming from fossil fuel in steel sector. Okay, and it needs very the huge amount, but also like, in terms of like the regularity of the energy that you need to build steel, right? It's used. So how do you think about, this addressing the challenge of a steel sector? How we can steel sector, how we can decarbonize, how we can make zero carbon steel, what are the technologies needed, right? So we look at from that is one of the key topic at the moment, and I think at the country level, at the national level in India also, we are thinking about like how we can decarbonize our steel sector, because we can put lot of renewable energy, but the question is, are renewable energy sufficient for the steel sector? And the answer is no, right? So what kind of maybe more innovative renewable energy technologies that we need to think about for steel sector, for cement sector, because they need huge amount of energy. Okay. Then we look at, for example, one of the example you see here, the second area, for example, is strategic minerals and supply chain. Okay. So we were talking about like the materials that you need for solar panel, the materials that you need for EV batteries. Okay. Where it comes from, like, what are those current materials? What are the new materials available? Can they be utilized? Right. So those kind of question. Which countries need to collaborate? What kind of interdisciplinary research need to happen to bring new technologies for, EV batteries, right? We are also looking at, for example, the third area, for example, AI grid, right? How AI, artificial intelligence, we are talking about. It's a digital innovation, right? How AI can, improve the grid infrastructure. Okay, how we can make the grid, the whole power system, make more efficient through AI. That's another area of research that is getting like really, really popular, and I think we need more people in India to work on this, AI and grid intersection. But you cannot work alone, right? Maybe to work on AI and grid intersection, you might need AI expert, and you might need the core power system expert who knows the grid. Okay, so how do you bring those two people together? AI people can talk about like AI, and the grid people and the power system people can talk about the power system, and then see where is the collaboration opportunities, what we can do together, what are the new breakthrough innovation we can bring, right? And that's how you also need to train the next generation. Okay. So these are the kind of areas, we are also, for example, one of the areas is climate, energy, and trade. Okay. Trade, for example, right, for the solar panel, we were talking about it. So a lot of materials come from, for example, China. Okay. So then India and China need to do this trade cooperation, to bring the materials for the solar panels that we are implementing, right? For example, European Union, EU, and India need to do some kind of trade agreement, right? To bring some of the materials from there to here and from here to there, right? So we are also looking at the whole set of governance and the policies and the rules, like, how that the trade between countries need to happen. Okay. We are also looking at the climate adaptation and resilience. So climate adaptation and resilience, especially we are looking at, and that's another big challenge for the, if you're doing energy research, that's another big challenge is what I showed on the first slide. For example, we are seeing like extreme heat. Last 10 years has been hottest on record, right? We are seeing more frequent floods. We are seeing wildfires, right? Because of climate change. So think about, with all these climatic impacts that are happening, we need to make the energy system more resilient, more strong, so that, there is, because of high temperature or because of, fire and other things, how we can protect the energy system, so that, if something happens, some extreme happens, we can still secure our power system. We can still kind of bring it back, if there is any climatic impact and damage to the energy system, how fast you can bring it back, and make the electricity available to people. So that's kind of another angle, is also very, very important area of research that I think we need to look at. Okay, next slide. Yeah, just a kind of a follow-up, the slide is talking about decarbonizing heavy industry, so just some example. For example, material science, how they can contribute, how the economists can contribute, how the policies can, policy experts can contribute. So I think it's again going back to that kind of interdisciplinary approach. Next slide. I was talking about this, for example, maybe EV batteries, right? So we are talking about lithium batteries, but where the lithium is coming from, right? Some of the countries in Latin America, like Bolivia, Argentina, Chile. These are the countries where highest lithium, material is there. So how when we are kind of these three countries have the highest concentration, Bolivia, Argentina, and Chile, right? But when you are kind of bringing them, who is using them, and think about like what are the geopolitical and ethical risks. Okay. For example, we are, a big discussion is going on. The countries who have these materials and minerals, they are mostly, the area where the material and mineral is, they are mostly the poor society, the poor country, the labor standard, maybe child labor is going on, maybe there are a lot of safety issues. So there are a lot of those kind of risks, that we are trying to solve. So for example, thinking from your angle, when we are doing mining for critical minerals for energy technologies, how we can make it more safe. Okay. Maybe that could be an area of research, what engineering can contribute to make a more safer environment for extraction of lithium. Okay. So think about from kind of those angle. Geopolitical is also becoming, issue. I was already talking about, we are our solar panel kind of value chain, a lot of materials are coming from China. Think about, the electric cars, the battery material is coming from maybe Argentina or Chile or, some of those countries. So similarly, whatever the energy kind of technologies that we are trying to implement, the green energy technologies, their raw material is coming from somewhere else, right? So it's called geopolitical dependency. We are dependent on other countries. Okay. For example, in our energy sector in India, there are, I'm forgetting the number, but the oil that you use in your car and scooter and bikes, that oil, the petrol and diesel, it's imported from other countries, and we are paying like billions and billions of dollar. Okay. So how you can reduce the dependency on other countries? In India, for example, we are talking about this Atmanirbhar Bharat. Okay. How do you become a self-dependent? And what you need to do, and how you can contribute from your research, from your teaching, how you can inspire the next generation to do some innovative research, so that we can become a Viksit Bharat by 2047 and become Atmanirbhar Bharat that we are talking about, right? Not dependent on other countries. Because if we are dependent on other countries, other countries use it, right? So this geopolitical dependency, it's not good for any country, right? So I think we need to think about from that angle as well, and your contribution, from your research and teaching. Next slide. And similarly, this AI, and I was already talking about in my the earlier slide, how AI can optimize grids. How you can use AI to make the more resilient energy systems. How AI can maybe reduce your home energy demand, your town energy demand. So think about like maybe you can do some kind of research, and maybe some courses, future courses can be developed on this intersection on AI and energy. At the same time, the AI is also using lot of energy because we need more data centers, we need more servers, right? So how we can make the more efficient data centers as well, right? Because all this AI that you are using, your for example, your chat GPT or perplexity, whatever the AI, technology you are using nowadays, there is a consumption, there is an energy consumption, right? And the consumption is somewhere happening in the data center in some server, right? And it's a huge amount of energy. Also, to cool the server, you need cooling energy, right? So all this like energy and water that we need for those maintaining the data centers, how you can reduce it. So this is another area of very kind of, I would say, emerging areas of research, that can be taken, and that can inspire the next generation, to do some innovative kind of breakthroughs. Okay, next slide. And the connection is key. I think what I'm trying to say here, you are as an engineer, as a technologist, think about innovation that can be really implemented in the society. And if your research and if your product that you are developing has to be useful as the society, then it has to be, you have to think at the system level. You have to think the interdisciplinary angle that we are talking about it. Next slide. The biggest breakthroughs are at the intersection. Okay, if you start collaborating with your power system expertise with the people who have digital expertise, who have AI expertise, and I'm telling you, that will be a kind of fantastic contribution to the society. So think about from that angle. Okay, next. This is just an example, for example, if you see the two boxes, at the, for green hydrogen, for example, right? There is a traditional mindset. If you are doing maybe a green hydrogen research, maybe you are picked up a problem and you are looking at it, with a very focused approach. That is very good, that is important, having the focus on a particular topic, is very, very important. But, would that the research that you are doing is going to solve the hydrogen challenge in India? Probably not. Okay, because you also need to start thinking about from an other mindset, what policymakers need, who is going to buy the hydrogen, where the hydrogen will be stored, where it will be produced, what kind of infrastructure you need to produce, right? What kind of a skill set is required to produce. So I think I'm not saying to do all the area of research. What I'm saying here is you need to have an understanding, when you are doing your research of all these areas, so that when you go and talk about it, you can talk about at the system level. Okay, you can talk about your research from a big picture perspective, and that's how you make the contribution to the society and the country and the economy. Okay, next. These are some of the kind of pathways. I think I was already talking about kind of partnership. So this is an example how we do it, and I think there is a lot of learning for you as well. Partnership and collaboration, I think it is very, very important. For example, if you're doing your research, also engage with, take the real question: what are the policy makers are struggling? Okay, for example, if MNRE, Ministry of New and Renewable Energy of India, is working on green hydrogen, maybe bring an expert, or maybe bring someone who is working on the hydrogen policy and ask, like, what is the challenge they are facing, right? And can you work on those, when you are doing research, work on the real challenge so that you can contribute, to the immediate policy need. Okay, so I think those kind of partnership and collaboration is important. When you are doing some research, don't think about, I have also done my PhD. I have published like, several journal papers and conference paper. But I'm telling you from my own experience, it is very, very important to think about, your research in a language that policymakers can understand, that technologists, in the private sector, can understand. Okay, so I think the research that you are doing, it's good to have a kind of conference paper, it's good to have a kind of paper in the journal, but take it to next level, then simplify it, develop a presentation, go to a policymaker, go to a conference where you can talk to a different audience, not just academics. Okay, talk to a different audience, get their views. I think that is very, very important, for the, of course, the visibility of your research, but then your voice can make a contribution, real contribution to the society. Convening and dialogue, I think this is kind of good that, the faculty development program is happening, but also as we are, I think, now I'm talking about from the more, from the policy angle, maybe you can have someone talking about economics of the technologies, the renewable energy technologies, right? So get those kind of perspective, have some kind of convenings and interdisciplinary dialogues. And research and publishing you are already doing, and teaching you are already doing. So I think those things are of course very important. The next slide. So think about, yeah, what lines do we need to cross next? Where is your research? and where you need to cross next. What is your research question and who is your partner beyond your discipline? Who is the most important partner beyond your discipline that you need to bring into your research? When you are doing teaching, maybe you are teaching, for example, power system. Okay, you are teaching a class on power system, or maybe you are teaching a class on power generation, or maybe renewable energy technologies. Maybe have some experts from outside in your class. Okay, bring someone from, who works in the private sector, maybe bring someone, a guest faculty from the government. So those kind of perspective can give we should give to students to think about, from the big picture angle. And similarly it goes, when you are doing your research, maybe you are in electrical engineering department, talk to someone in mechanical engineering, talk to someone in material engineering, and do those kind of interdisciplinary within engineering, but also kind of going beyond that, to solve the challenge. Because if we keep working in our own discipline, I think the challenge we are not going to solve. Let me tell you that. Okay, and we really need to take an interdisciplinary and systemic approach. So I would end here. I think I don't have any other slide, but happy to take a couple of questions. Yeah. Next, I think 5-7 minutes should be okay. So maybe we can remove this slide share. And I know not many people come on the screen, but if you want to come on the screen and if you want to ask few questions, I think I'd be happy to respond. Or if you have any thoughts, like any perspective, what I shared. So feel free to come in.
Sir, can I ask one question, sir?
Yes.
Sir, can you
Good to see you, Satya.
elaborate that? Yes, sir. Nice to see, sir. Sir, I need a small information about the decarbonization. What you have delivered. I need some elaborate about decarbonization, sir. Decarbonization.
So decarbonization, we call it, for example, when we are, our energy system, that we are using, it's completely, our whole economy is fed by fossil fuel. Okay. What is fossil fuel? Coal, oil, and gas. Okay. And coal, oil, and gas makes lot of carbon emissions. Okay. So the carbon emission is going into the atmosphere. And because of that, the first slide that I showed, the temperature is increasing, the weather is getting more hotter, the more fire we are seeing, right? So all these issues is coming from the carbon emission. Okay, or in the broader, we call it greenhouse gas emissions. Okay, and the greenhouse gas emission is coming mainly from, this the fossil fuel that we are using. So the use potential, if you want to make a better environment, the use potential is in the energy sector. Okay, because energy sector uses, most of this kind of fossil fuel. Okay, and releases most of the emission. So what I'm trying to say by decarbonization is like carbon. Okay, so we are releasing carbon from energy. So carbon and decarbon. So that's what he called decarbon, means put renewable energy into the energy sector, into our transport sector, put renewable energy into our homes, put solar panel on your homes. Okay, put solar panel on the university. So that's what's we. So the carbon and D. So that's a decarbon, and the process is called decarbonization. Okay, so the decarbonization is nothing but it's bringing renewable energy into every parts of our economy.
Okay, sir. Thank you.
Any other question?
Thank you very much, sir, for your insightful session. We request the audience, participants, please interact with our resource person. If any participants are having any questions, please interact with sir.
The audience seem to be very shy. Nobody's even coming on the screen. And I always like find that, whenever I do any talk in India, But I think we need to be more, yeah. I also come from India, so I very much I understand, right? I was also born and brought up there, studied there, but yeah, I think we need to be more. Yeah, it's a kind of rare chance also when you get people from like joining from different countries or people from different disciplines and different sectors, like I think it's a rare opportunity also to get others perspective, learn from others experiences. I think uh, I did this. I just after an hour I finishing this talk, like in next 1 hour I have to catch a flight. I'm going to Brazil because there's the world's biggest climate conference is happening, and I'll be launching my book there as well. I think I had my book on the slide. I didn't show, I think, but anyway, yeah. So I'm launching a book. It's called Energy for Billions. And I talked about this whole interdisciplinary approach, and the book is coming out next week, hopefully on Amazon. So the book will be talking about like why we need to think interdisciplinary, why we need to think at the systemic level, and it's called Energy for Billions. So what I'm trying to say, I thought like it is important to talk to you and give some kind of from my own life experiences, whatever I can share, and if it is helpful to you, you can learn and maybe implement in your own kind of research journey and your own teaching journey. So yeah, if there is no question, I think
Sir,
we should
sir,
close
sir.
it.
So what is the title, sir? Title of the book?
Book is
What is the title of the
Energy
book,
for
sir?
Billions.
Okay, sir.
Energy for Billions. So it's a India's story. It's a book. Yeah, I wanted to show that, but I think because I did not have
Sure.
that shared my screen. But the book is about. It's a kind of a personal journey as well, because I was born and brought up in a rural village in India where there was no electricity. So first 13, 14 years, I did not have electricity. And then I gone into this journey. So the book captures this my personal journey, plus also the last kind of 10 years, that is the renewable energy revolution that we are seeing in India. So I have brought this kind of interdisciplinary approach, like how all the sectors are working for the renewable energy boom in India. Okay. And then also thinking about the Viksit Bharat. Okay. So Viksit Bharat is like 2047. So book is bringing three parts. One is the personal journey. Second is the last 10 years renewable energy revolution in India, and the 2047, what we need to do. Okay, so I think it should be available in Amazon next week, hopefully. So the book is Energy for Billions. So yeah, definitely it should be. You'd be able to access it.
Great.
Super, sir.
Sure,
That's very
sir.
inspiring for us, sir. Sir, I have a small question, sir.
Yeah.
Sir, before that, thank you so much, sir, for your insightful session. It's truly inspiring us to see how your academic expertise is shaping global energy and sustainability policies. So the question from my side is, sir, how do we see India's energy policy, which is aligning with the global sustainability goals, where the India has some goals of 2050 like that, we heard, and especially in coordination with the other countries, with the major economies. How can we see India's policy, sir?
Yeah, no, India has come, if you see the growth rate, like, in terms of like our economic growth, that has also kind of rapidly accelerated over the last decade. But let me talk about from the energy angle. Okay. In energy, because I work on energy, right? Energy is the kind of acceleration that we are seeing, it's, I would say, of course, in the world, China is ahead. China is like number one in the world in terms of putting solar panels, building wind turbines. China is just in last year in 2024, the amount of solar panels and wind turbines that has been put in China is far more than combined all over the world. Okay, so what the solar panels and wind turbine has been put all over the world, that is one side, and what China has put, is one side. China is far greater than all over the world. Okay, so China is like way ahead. But in terms of like, if you think about how we are doing, sometimes we don't need to look like outside. We need to look outside, right? But sometimes we also need to look at how far we have come, right? We were a country where electricity access was a challenge, right? Many parts of the country did not have electricity access. And in just last 10 years, how far we have come, we have now almost, electricity access in every village is connected in India. And then the renewable energy revolution, okay, that we have built. 50% of our electricity, the India's electricity sector, 50% of electricity is coming from non-fossil fuel. Okay. Now, and that target was 2030. So India needed to achieve that target by 2030, and we achieved in 2025. Okay. So just one example,
Great.
we achieved our own defined target 5 years ahead the deadline. Okay. So this is just an example, but there are so many things happening in India, and of course, a lot of credit goes to young generation, and the youth and the startup boom, and how people are kind of contributing. I'm seeing, looking at from outside, I've been like almost 12 years now outside the country, although I travel very frequently to India. But I think now there is a new drive and passion. There are a lot of things going on in India. But at the same time, I think we need to take it to next level, right? I gave you example of China, how China is
Yes.
doing, right?
Yes,
Can we
sir.
do what we are doing now is commendable. It's an excellent job, but where we can take next, like our country, right? And how we can put more effort in building a country, because the next 30, 40 years that we have is very, very critical for India. Okay. In the next 30, 40 years, if we are able to contribute, and we all are engineers and working on energy, and right, so if we are able to contribute, from our own perspective, from our own research and teaching, I think next 30 years, we'll be kind of one of the, one of the most powerful country, but if we are not able to do in next 30 years, the another turn for India, will come maybe after a century, after maybe 2 centuries. So this next 3 decades is very, very important, because we are the most kind of, highest young
Young
generation
generation.
population we have, right? So I think, we need to make the most of it. And I would definitely request all of you to work more sincerely, work more hard, and work for the country and for the society, for our, we need to take the country to the next level. And it's like everybody need to contribute. It's everybody role, sometimes we don't see it, because we are very much into, we call it tunnel thinking. Tunnel thinking is like you are looking in a tunnel, you are just looking at like this. Sometimes we need to open our eyes, we need to have a broader picture, and then, you can see like how you are contributing to the society. So with that, yeah,
Yeah.
that's what I would
Yes,
say.
sir. Yes, sir. That's very inspiring for us, sir. And
Great, sir.
it's very good and very great to hear from you, sir. So, sir, one last question, sir. Simple, just wait, sir. Sir,
Yeah,
how
and
can we
then
see
probably I
the
might need to leave in 2 minutes. Yeah.
sir? How can we see the investment opportunities in future, sir? Means with respect to energy side or with respect to any climate side. Do we have good investment in future, sir?
It's a huge investment, right? There are still, as I said, a lot of work. Green hydrogen, for example, right? Hydrogen technology is just starting, right? If you see solar and wind, it's just starting, right? We haven't done, at the scale that we need. So all these technologies, our kind of 2047. Okay, what is 2047? Viksit Bharat. What is Viksit Bharat? One of the key pillar of the Viksit Bharat, make India an energy independent country. Okay. For example, I was saying we are purchasing oil from other countries, billions and billions of dollars. Okay. So how we can, do in our own country? What kind of research? What kind of technology development? What kind of piloting? What kind of projects need to happen, right? So all this, what is this? All this is investment, right? So our country, is making an investment. There are a lot of like public sector is making, government is making investment. There are a lot of private sector investment is coming, right? There are a lot of investment coming from other countries as well in India, because because of, so many other reasons, right? Because countries want to invest in India. India is growing. India has the highest middle class population in the world, growing middle class population, so I think huge investment is going to happen. There is no doubt about it. And I think energy sector is one of the most important sector at the moment. So if you are working on the energy related technologies and policies, I think you are at the best place at this time.
Thank you, sir. Thank you so much, sir. Thank you very much for your detailed explanation, sir. It's a final call, dear participants. If you have any questions or if you want to interact with the famous person, please utilize the opportunity.
Yes, sir.
Yes.
Sir. Yes, Namaskar, sir.
Namaskar.
Sir, first of all, congratulations to you, sir.
Thank you.
For book, that is energy for billions.
Thank you.
Very nice session conducted by you, fruitful session for us. One last question, that what is the meaning of carbon footprint?
Carbon footprint is, see, it's footprint, right? It's footprint. So and print. So when, how we call it, it's carbon footprint. Okay. For example, let me give you a very simple example. In your one day, okay, you wake up in the morning, you are using some water, you switch on the light, you are using electricity, right? You are washing your face, maybe you are using water, right? Maybe you are going to walk, you are driving bike or scooter or maybe car. Okay. So all this is energy, right? You are using oil in the car. That's an energy. You are using water. The water is coming from somewhere. Some motor and pump is pushing the water to your home, right? So that is also consuming energy. You are switching on the light or fan. That is also consuming electricity. So all this electricity, that you are consuming in your day, this electricity is where it is coming from: coal, oil, and gas. Okay. For example, maybe you have solar panels, but think about, what the situation, in many homes. Okay. It's coming from coal, oil, and gas. Okay. And as I was saying earlier, this coal, oil, and gas, they emit carbon. Okay. So in one day, whatever activity you did, okay, it consumes coal, oil, and gas, and that emitted carbon. Okay. So that energy, maybe you use, like, for example, maybe 10 kilowatt hour. So 10 kilowatt hour, is converted into carbon, how much emission you made. Okay. And the emission that you made, carbon emission, that is called carbon footprint. Okay. So maybe in one day you are 50 ton of, so the carbon is ton of oil equivalent. Okay. That's the unit. Okay. Like we are saying kilowatt hour. Similarly, we use ton of oil equivalent. Okay. So maybe in one day you are doing like 50 ton of oil equivalent, emission from your own life, in one day. Okay. So that's called carbon footprint.
Thank you, sir.
Okay.
Thank you.
Okay.
All right.
Dear participants, if you have any questions, please last so that we'll wind up the.
I think I need to leave now, Kasirati. Otherwise, I'll miss my flight.
Yes,
I need to. Yeah.
Sorry, sir. So finally, yeah, we are truly honored to have Dr. Piyush Verma, sir, with us today. So a distinguished academician who has seamlessly bridged the gap between research and real-world policy. His remarkable journey from academia to the global policy arena, particularly as a policy head at ORF America, stands an inspiration for all of us who aspire to see knowledge translated into an impactful action. So thank you very much, sir. Thank you very much for joining us. Thank you very much for sparing your prestigious and precious time with us for our ACT Atal FDP. So finally, we'll close the session. So Thank you very much for joining us, sir.
Thank you, everyone,
Thank you,
and
sir.
good luck with everything. Thank you.
Thank you, sir.
Happy days. Bye.
Sir, mute all. Yeah, dear participants, We just concluded the session 3. Sir, who is a IES, Deputy Director, Central Electricity Authority, New Delhi. So before that, we'll take a short break, and the next session will be starting by 7:30 p.m. Okay. We request all the participants to please stay connected. Okay. So that we'll be having a follow-up, and we'll be starting the session at sharply at 7:30 p.m. Thank you very much for your cooperation. Thank you. Sir, Sri C.H. Rajesh, sir, are you there, sir, in the meeting, right? Sir?
Sir, am I audible?
Yes, sir. Now you are audible, sir. Yeah,
Just
with
a
your
minute.
permission, sir, with your permission, yes, sir. With your permission, can we start, sir?
Yes.
Okay, sir. So thank you, sir. Thank you very much for accepting our invitation, sir, in spite of your busy schedule. So we, on behalf of Vishnu Institute of Technology, Bhimavaram, cordially invites you to AICT Atal FDP, sir. So now I'll be introducing our expert. Sri Rajesh Kumar, sir, is currently serving as Deputy Director in the Operations Division of the Southern Regional Power Committee, SRPC, Central Electricity Authority, Bengaluru. He holds a BTech in Electrical Engineering from JNTU Kakinada and an MTech from NIT Calicut. He began his career with BSNL as a JTO Electrical, where he worked for 5 years. In 2013, he cleared the UPSC Engineering Services examination with an All India rank of 79 and subsequently joined the Central Power Engineering Services. He has previously served in the Electrical Inspectorial Organization, Chennai, contributing to enforcement of electrical safety standards and supply-related regulatory measures. He later moved to CEA headquarters, New Delhi, where he was associated with demand forecasting for the 20th Electric Power Survey and carried out analytical studies on DISCOM consumption categories and captive power plant data under the Northern region. He was also part of CAE's initiative to develop a dynamic electricity demand forecasting tool, enabling states to visualize short-term demand up to a month ahead for improved planning and resource allocation. In his current role at SRPC operations, he plays a key role in ensuring secure and reliable grid operation within the southern region. The operations division is responsible for conducting OCC and SRPC meetings, addressing real-time and long-term operational issues, and ensuring compliance with IEGC provisions, CERC regulations, and policies framed by CEA and the Ministry of Power. Further, he is actively involved in coordinating with all southern region constituents, utilities, generators, system operators, and transmission licenses on their operational requirements, facilitating informed decision making through the OCC SRPC forms. His work supports periodic operational reviews, grid performance assessments, outage planning, and seamless regional coordination, all of which contribute to maintaining the reliability and resilience of the southern regional grid. So with this, we are very honored to have you, sir. Thank you very much, sir, again for accepting our invitation. So with this regard, I request Sri H. Rajesh Kumar, sir, to address the gathering. Over to you, sir.
Am I audible?
Yeah, yes, sir. You're audible, sir.
Yeah. So thank you, Vishnu Engineering College and even ACA for giving this opportunity, which helps many people. This FDP emerging trends and technologies and application. So yeah, so myself Rajesh, and I'm connecting from Bangalore right now, and I have small PPT. Which I'm going to talk about RE policies, regulations, and grid integration and role of CEA in that. So can someone confirm whether my presentation is visible?
Yes, sir. Yes, sir.
Okay. Okay. Thank you. Yeah. So I have I have segregated my presentation in 4 parts, 5 parts. One is what is the present status of installed capacity, and then generation also.
Yes, sir. Yes, sir. It is visible, sir.
I'm audible now?
Yes, sir, you are audible, sir.
Okay, thank you. So this is the flow presentation. So few things, because of the time constraint, few things I go in detail and few things I'll just give a overview of all these things. I talk about NEP, what is a brief overview, and then why integration is important, especially RE integration, and what are the challenges in general, because we have very huge goals, huge aspirations. India is growing, and the power sector, growth of power sector is equivalent to the Indian GDP as well, right? So how exactly RE plays a major role. Okay, so why we are focusing more on RE, and at the same time, what are the challenges and how do we mitigate them? What are the steps that has been taken? In the process, what are the policies and regulatory frameworks to promote RE or integrate RE? So these are the things that I'm going to discuss. So yeah, Indian grid, nothing to say about it because we are almost national when it comes to synchronous grid. Okay, one grid, one nation. We are number one when it comes to synchronous grid, and in coal generation we are in the second place. And when it comes to generation and consumption and IC and transmission systems, we are third. Wind and solar we are 4, and hydro generation 6, and pump storage capacity is 9. So, I mean, when it comes to power sector, we are really leading the world. However, so these are the statistics I want to project. This is up to 2024, where fossil fuel-based capacity is 53%, like thermal power plants, coal, lignite, all those things. And large hydro, it is 10%, which is more than 25, because up to 25 now it is categorized as RE only. So RE is 35.16. So I have two statistics. One is up to December, and that is as per the CEA plan, and another one is up to August 2025. Both I will share upon what is the difference you can observe here. And the total we have installed capacity of 462. Okay, so nuclear is 1.7. We are coming up with small nuclear power plants also. So which NTPC is working on that majorly, and yeah, this is the latest one. Where if you see like the difference between installed capacity by December and August, so 7 gigawatt difference is there. Sorry, 30 gigawatt, 25 gigawatt is there. So this is the latest figures where hydro including PSP is 18% and addition. Okay, so if you see RE, it is increasing like anything, right? Small hydro 272%, solar PV is solar it is 138, and wind it is 90%. So these are all the installation that is keep on adding. Okay. So why are we moving towards RE is because of this COP26, which was held in 2021 at UK Glasgow, where nationally determined contributions, NDCs we say. So we committed to reduce to 45% emissions from which was from 2005 to 2030, which is very high in fact. Okay. So, and achieving a cumulative electric power installed capacity of 50% from non-fossil fuel-based energy resources by 2030. So, very huge, goals. So, due to which, we are supposed to increase our RE share in the grid's carbon intensity. Earlier, if you see, thermal, it was around 60-70%. Now we are moving in such a way that it is coming to around 50%. Okay. So in the process, our goal is to achieve 500 gigawatt by 2032. Okay, so 2030. So, and emissions intensity of grid electricity has also dropped. Emissions also dropped in the last few years after we have taken this oath as per the COP26. So 9% in the last 9 years, which is very significant difference of reducing this emissions, carbon emissions. So it reduced from 0.77 ton carbon dioxide from megawatt hour to 0.71 in the last 5 years. And subsequently, as per NEP, National Electricity Policy, so we have a target of reducing till 0.43. So these are the breakups of REs. Wind power is around 30% and solar is 60%. So this is again up to December. Yeah, so this is also similar one, which is different pictorial graph of RE source wise. Conventional sources is 80% and large hydro is 5 when it comes to by December 2024. Now, how India's journey with renewables? Okay, so if you see, renewable is not equally distributed all over the country. Okay, so there are different places. Installation is more and depending on the geographical conditions. So everywhere, the climate is not same, right? So if you see, Tamil Nadu has 77% installation percentage, and maximum wind plus solar penetration. If you see, Andhra Pradesh has 86% and Tamil Nadu 77%. Telangana is 65%. So likewise, every state has a difference in this, right? So highest instantaneous RE penetration is recorded on 6th July. That is 33%. Into the grid. I'm talking about the grid. So that is, very high, in fact. Now we'll talk about NEP because now we have some goals like 500 gigawatt, right, by 2032. And what is exactly demand, where we need to reach, and accordingly installed capacity, all these things. CEA will always take care. CEA is a technical advisory to MOP and Government of India. So we closely work with CERC and other technical bodies of power sector. So this NEP is one major thing that we publish so for every 5 years, CPS will be there. So this is a review of generation capacity addition in the last 5 years of, 2017-22, and the upcoming will be 22-27. And perspective plan for 27-32 is also coming. So we have already published 22-27. So which covers all the inputs, like, what is the fuel requirement in future, and, infrastructure requirement, everything will be covered in this NEP. You can see here energy requirement, how much it is, and peak demand is also how much it is. So this includes impact of various factors like, transmission and distribution losses. And glad that I'm part of 20th EPS, when I was posted in Delhi, Northern region, where various categories we will collect, and we forecast up to 2031, 32 based on, based on the discounts growth, or how exactly are they growing, how exactly year wise we ask their details, and then accordingly we do the forecasting figure with the tools that we have, and it will be further approved by head of chairperson also. So we consider all these factors like transmission, distribution losses, and energy efficiency improvement measures. And even we consider the prices also, and production of green hydrogen. Everything will be covered in that. So if you get a time, go through that. It is a very interesting report that always CEA publish. And apart from this, not only 5 years, now we are aspiring, we are creating one tool where we can forecast all these figures, whether it can be energy requirement or peak demand up to 1 month also, which is very significant. Significantly we can handle the load and grid also. That's how we can adequately utilize our resources as well. So this is the projected installed capacity as per EPS 20th EPS. So it is 609. We are at right now 405, right? 405 gigawatt. So, and out of which BESS is also expected around 8. And this is up to 2030. It is 777. And you see, you can see the difference in 3 years. BESS is going up to 41.6 gigawatt from 8.6, which is almost 33 gigawatt. So why? Because of the RE. So the more the RE, the BESS is also, we have to plan accordingly. Why exactly it is important? What is the role of this what is the role of BESS and PSP in the as a part of RE integration? I will discuss in the further slides. This is 2032, where projected installed capacity is 900 gigawatt and BESS is 47. So, and solar you can see here 364 gigawatt. So still, you know, MNRE is completely working with the solar installation and all. So we are mainly focused with other aspects of RE, okay, like integration and bringing up policies, regulations, all those things by coordinating with MNRE and MOP, all those bodies. So before I talk about generation dispatch on peak demand, you know, which you know, this is not installed capacity, it's on a particular day. So how exactly demand variation is happening. So before I talk about this, we will go into the uncertainty, what exactly the operational uncertainty that India is facing when it comes to high RE addition. Okay, so you can see here the more RE, I mean solar and wind. Okay, so much of RE pooling stations at EHV level comes. Okay, so because when you are more and more installing, then you need to see the evacuation path also, so that there should not be any transmission constraints. Okay, at the same time, the corridors, you know, that interregional corridors should be sufficient enough. The transmission lines, whether it is at a level of EHV or you know 400 kV level. And you know harmonics that are coming from you know RE, these all things needs to be handled as per the policies and regulations. Okay, so this is the uncertainty you can see here. So if there is a you know all of a sudden you know if there is a rain, okay, or you know cloudy season is there, okay, so cloudy situation is there, then automatically all the solar comes down, right? So you can see here on 6th July, Saturday, all India demand is 195, peak is 195 gigawatt during solar hours. And the role of solar is here 34. Okay, so 34 gigawatt and wind is 25. So, and hydro, small hydro is 21. So altogether 30% RE is there. Okay. So on non-solar hours, that RE is 12%. The role of RE is 12%. So from 4 o'clock to 5 o'clock, okay, where solar, you know, diminishes slowly. That is, you know, you don't find any solar energy. So that 18%, how do you handle that? How do you complete that gap? So this is what we plays a major role in handling the demand. Okay. So cloud covers and extreme events like recently Monta, you know, Tufan has come, right? So lot of disturbances in the grid. So many warning messages, so much of disturbances because you know RE penetration is completely reduced, and it is completely not only reduced, it's uncertain in nature. My point here is RE is uncertain in nature, especially wind. Okay, because we don't have enough resources to forecast the wind as compared to solar. Because solar, when it comes to solar, so it is significantly we have improved with the help of FSPs, forecasting service providers, which every state work on this daily forecasting and real-time monitoring, and then weekly forecasting and monthly forecasting. So they get the data. But when it comes to this some calamities or unfortunate situations, it is very difficult to handle the grid. And once if the grid fails happens, so it is very difficult to again bring back all the generation, all the transmission units. So we should be, that's where you know grid code also plays a major role in handling the frequency from 49.5 to you know for 50.5. So this is how we handle the grid frequency, and accordingly RLDCs and SLDCs along with the CEA works together in real-time RLDCs and SLDCs work. And when it comes to policies and planning or any constraints if they are facing, CA will take care. So not only RE uncertainty, there will be, as I already told, like Montar Tufan, there is a, if you remember, like in April 2020, our Honorable PM called for solidarity call, like, during COVID likes of situation. So, all of a sudden, everyone switched off their lights, everything happened, right? So if you, if generation happens at that, at the same level, and if there is no demand, so what happens? The frequency will be very high, right? So if the generation is high and demand is less, so more pumping happens and frequency will be more, and automatically, grid failure happens. So it was a planned NLDC. It worked like anything on the day. You can see here ramp down of thermal, ramp up of hydro. Both happened at a time. Okay, so at 8:30 and 8:46, hydro ramped up so that frequency can be maintained properly. And thermal, you cannot. The ramp rate of thermal is very less. Okay, so it's a sequence of events that happen. So as I already told, like Manta event, this is also one kind of event. So you should be always focus on integrating. Grid integration is always important. That can be with the RE. However, we focus mostly now with RE. You can see here duck curve. Okay, duck curve. If anything happens in daytime, okay. So if you see 43 gigawatt difference is there. When if something goes wrong, how do you handle that? Very, very important. So, and when all of a sudden, if some rainy situation happens, so nature and real time it changes, and because of RE uncertainty also increases in demand side. So that is where in future EV charging and data centers, because we are getting all these things, right? EV charging stations, we are moving towards EV vehicles, and data centers are more, more data centers are expected to come, and then induction cooking is also coming into picture. Everything is reliable on power. So, and if you see in the demand projection in north is different from the south. South, the peak demand will be in the evening time, like 8 to 10 or morning 6 to 7. These are the peak times that happens in the south. When it comes to north, it varies from again season to season as well. Right. So this is how integration of RE and non-renewable energy strategies in the Indian context. It is very important. Declining of LCOE of renewable energy, and then growing know-how and experience with large-scale renewables. Okay, so and global availability of renewables. So these are all renewable energy generation capacity. So how we are yesterday and what we are going to do, and then what is going to happen tomorrow. So even fossil fuels cost also keep on increases, like that can be coal, lignite, and there is an even increasing need to protect the environment also. That is what we are talking about, COP29, right? And of course, global availability of renewables like solar, it is available anywhere, right? And wind is also, you need not do anything. So it is available. Only thing is you need to grab it with a proper way. So when it comes to challenges, these are the realistic challenges, because RE is variable in nature. So wind and solar RE generation are variable and intermittent in nature, because some period of time it will be there. Like wind will be very high in southern region from few months from June to September to December, like that. Okay, so these seasonal weather patterns will be there, and daily also it varies. So that will lead to frequency and voltage excursions also, like where grid operators would escalate to higher penetration of REs, and it is very difficult for the grid operator to balance both demand and supply along with RE, and sufficient inertia is also required in the system, like reserves. Okay, so all of a sudden, if RE goes down, how do you, operate or play the game with, reserves, like, tertiary reserves, secondary reserves, primary reserves. So I'm not going in detail. That comes under the grid operation and impacts to fossil fuel generators, like, So if you see fossil fuel generators like thermal generators, thermal power plants, there are more wear and tear. There is more thermal stress. If RE is going up and down, accordingly, power will be should be generated by these thermal power plants, right? So that means if they are going up and down, means more wear and tear will be there. And of course, there are with the solar, there are communication issues also. Real time, we cannot get all the telemetry data. It is not available everywhere. Solar is far better compared to wind. And more reserves are also required at the time of, as I already told, sufficient inertia. And the resilient transmission network. This I addressed, right? When more in RE is coming into picture, so accordingly, you need to upgrade that transmission network also. So there is a separate wing in our CE also. They, PSPA, power system, planning and appraisal wing. So they based on the reasons, they take care of this transmission network. And grid services like, primary and secondary responses, also, from wind and solar or other equipment at added cost, it comes. And existing conventional generators, let's say if RE is more and, generators, conventional generators like more than 25 years, if we are not running it, frequently, so the price that we have invested on that, it cannot be recovered. Okay, the more it runs, then fixed charge and, variable charges. So that per unit, even if we don't run it, fixed charge will be going to that conventional generators, because most of the conventional generators are part of, Section 62 of Electricity Act, where, this NTPCs, all those comes under that, generators. And thermal generators, mostly I'm talking about NTPC. Okay. And what are the solutions do we have now in our hand? If you see, we need to better utilize this geographic diversity, considering solar insolation and wind pockets. Let's say if wind is very high in bottom south, like Kerala, like Tamil Nadu and some parts of Andhra, it is very high. Okay, and then when it comes to again, so wherever sea is there, so more differences will be there. Wind differences will be there. Accordingly, more wind will be there. And then due to that wind difference, more wind will be there. So we need to utilize there itself. And we cannot keep anywhere, wherever we want, like, solar also. So it should be very geographic diversity. That is what very plays a major and, crucial role. And improve RE and load forecasting. So yes, load forecasting, now we have some idea about it because of so much of data and, so much of analysis, and this 24/7 power supply. These all things forced us to do proper load forecasting. However, RE forecasting, still we are developing that. And in our regular meetings also, we ask all the states to come up their own forecasting methods. And South is doing really good in that. And when it comes to sharing amongst balancing areas, yes. So if you see in the initial slides, I have shown about the RE percentage among different states, right? So that interstate corridor should be good enough. Like SR is there, and NEW, we will say, like north, east, west, that grid, and which is connected, SR is connected with that. So let's say more RE we are importing from NEW. So that corridor should be good enough. Likewise, if we are importing more power from east side, so that corridor should be good enough. That's why we should have very strong HVDC, and HVDC network system is important. That should be more balanced. And at the same time, enhanced variable, RE services, like, primary response. So as per CEA connectivity regulations, we have to implement that. And flexible loads, we should coordinate as per active demand response, we need to coordinate with between the flexible loads and utilize that flexible conventional generations and expand transmission. And of course, we should add electrical storage for having the more integration, because whenever power is very cheap, like sometimes you get power at 1 paisa also, 1 paisa per unit. Okay, so at that time we can store energy that can be in the form of BESS, battery energy storage system, or storage plants are also there. Okay, pumped storage plants. So likewise, we can store it when it is very less, and then when it is required, like evening hours, when it is required, we can use that power again whenever demand. If you see, so nowadays, so many discoms to meet that demand, they are buying the they are buying the power from market, real time market, at 10 rupees per unit. So it is mandatory to supply the power for the nowadays to all the consumers, or that may be commercial, that may be domestic consumers, that may be industries, and they cannot say no. So how they are, if we have better electrical storages, then we can, whenever the power is cheap, means RE is very high, so then we can use it properly in a better way. And then when RE is less, we can again use that storage. Okay. So now when it comes to solution, supply side flexibility solutions are there, and the grid flexibility solutions are there, and demand side flexibility solution are there, and system wide storage flexibility solutions are there. So if I go in detail, supply side decreasing VRE generation uncertainty, that means more forecasting techniques, and flexible generation to accommodate variability. So that we are going to talk about it, flexible generation, thermal power plants. How are we able to operate them very flexibly? So I have a few slides which I will discuss about it. And grid flexibility is also important. As I already told, interconnections and regional markets as flexibility providers, and matching RE generation and demand over large distances with super grids, like big substations, are very important, and large scale storage, the BESS related, that is very flexible, that will be helpful for the grid also operation point of view. And demand side, so we need to focus on even on discom end, like we can have small whatever RE is there. Now what we are doing, since because of very high huge targets like 500 gigawatt, we are putting, when some private player is interested, we are allowing 100 gigawatt, 200 gigawatt, 10 gigawatt, 20 gigawatt. Likewise, we are allowing them to install it. That is fine. But at the same time, we should encourage some 5 gigawatt, 10 gigawatt in the local areas, like in the villages, so that aggregating distributed energy resources for grid services. So it will be more helpful in handling the demand side also. If something goes wrong with the, so any interconnecting path, then that local area can handle it. Okay. That is what demand side management is also equally important. Mini grids are providing services to the main grid. It should be equally distributed, and optimizing distribution system operation with distributed energy resources. So these are the demand side. When it comes to system-wide storage flexibility solutions, so utility scale battery solutions and power to X solutions. What does it mean is, like if you see, when you convert RE into clean RE into clean energy carriers like hydrogen, synthetic fuels, or heat, which can be stored, transported, and used in sectors that are hard to so electrify. So any green hydrogen, all those things, you need a power, right? So that way we can use this RE also. That is what flexibility providers in the in the current power system, and we should we should bring those opportunities also, so that it should connect to every node. Now, what are the developments that happen when it comes to RE integration? So one is CEA has brought technical standards for connectivity to the grid. We have laid down regulations that minimum technical requirements for RE generating plants to ensure the safe, secure, and reliable operation. And compliances also, as the above regulations by RE plans, and it should be verified jointly by C2IL and state utilities and RLDCs and SLDCs before granting connections or interconnections to the grid or state grid or ISTS. These all they have to follow all these technical standards, and requirements with respect to dynamic reactive power support from the generators are covered in the again technical standards for connectivity to the grid regulations. Power equipments like STATCOM, synchronous condensers are also should be planned for dynamically varying reactance support in the grid, because when you have more and more RE penetration, then so many disturbances will be there. So like harmonics, and they should also equally support the grid by penetrating more VAR also. And IEGC also, it mandates that RE plans participate in primary and secondary frequency control. Whenever frequency drops, they should support in case of any contingencies that IEGC talk about it. Demand response also, it is considered as a resource in IEGC. Deliberate reduction in electricity consumption by end user in response to incentives to shift their usage from peak demand periods. So demand response in the sense like whenever power demand is there, so that time, if possible, we need to shut down few major items so because some penalties will be there if you CMD is more than whatever contract maximum demand is there. If the usage is more than that, then automatically there will be penalties. So to these kind of things, the demand side discounts will take care of. And so flexibility in conventional generators, CEA already has brought for thermal power plants MTL, minimum technical load. So is 40%. So now in a phase wise, we have reached that. So this is what thermal flexibility is equally important here. And why it is very important is, so when inconsistency and intermittence of solar and wind powers has to be managed by other sources, right? So if there is no generation, proper generation or irregularities with solar and wind, grid will be unstable. To handle that, thermal flexibility is important. So that this is security or reliability. This is very secure and reliable power source, thermal power plants. Okay, and because coal and lignite based generation capacity almost 217 gigawatt, almost 50% of total installed. So you cannot avoid this, and it is non-negotiable to take the power from the thermal power plants. And more than 70% of country's energy demand is being met. Okay, from this thermal generation. So you need to integrate this also. Main focus must be there. And yeah, so when it comes to electricity authority, we have as per the section 177, we have a power of doing regulations on installation and operations of meters, grid standards, technical standards for connectivity to the grid, and measures relating to safety and electric supply, and technical standards for construction of plants and lines, statistics and information. These all things we have the power. We can ask the information and we can frame accordingly for the benefit of Indian power sector. And safety requirement is also important for construction and O&M of power projects. These all policies and regulations will be framed out and it will be gazetted with MOP. So this MTL, I'm talking about 40%, but before reaching 40%, so far 60-70% all the generating, super critical thermal power plants are reaching, 60, they're operating at 60 and all, and they are stating so many constraints. So for which, there was a phased out plan CEA has come up with, in January 30, 2023 for flexible operation. And whoever operate at MTL, at 55%, accordingly, they will get incentives because it is supporting the grids, right? So, and with a proper ramp rate, the more speed, if the thermal power plant is able to reach out, then, if they are able to operate at certain period, that period, they'll get incentive. That commercial aspects I am not touching upon. So 55 to 70% ramp rate is 55% along with ramp rate of 2%, and between 55 to 70%. Yeah. Yeah. So end of the day, we are supposed to reach to minimum power level of 40%. That is the target. And implementation is happening in a phased wise, and it is being monitored by CEA and RPCs also. From time to time, we are monitoring that. And present status, so for figures point of view, I have shared here. And by January 2025 is the present status for 55%. And when it comes to 40% is more important. We are operating as per the phase wise. So ramp rate is 1%, 40 to 55%, and 55 to 70% for 2%, and 3% per minute for 70% to 100%. So ramp up and ramp down. So when it is ramping up 40% to 55%, 1% ramp up is important. And when it is ramping down 55% to 40%. So this is the phase-wise plan. It is already there on our page. Pilot phase 10 units are already part of this. Then phase 1 91, phase 2 100, phase 3 101, and phase 4 191. It's this 40% TML is not up to the mark. We are still focusing on that. Yeah, so there are so many technical problems that when they operate at 40%. So these are the modifications proposed after a few units has operated 40%. Ramp rate, minimal load operation, and heat rate efficiency. So what are the challenges that they are facing? Everything was mentioned. And what are the policies for RE promotion or RE integration that I will talk upon? First, generation point of view. So we must run priority dispatch statuses for all the renewables, for which MOP has already given one notified electricity rules 2021 for promotion of generation, which mandates that RE projects, including not limiting to wind solar and wind solar hybrid, must be considered as a must run project. So you cannot avoid that actually. So because of these goals, MOP has released this, and these projects shall not be subjected to curtailment. And if any curtailment like transmission constraints happened, then you cannot curtail RE. Okay, so you can curtail thermal. First priority, we should give supply to RE because we cannot store it, and whenever energy or wind is there, or sunshine is there, like sun is there, then that will be waste. You cannot curtail. And extreme cases only we can curtail. Any grid failure happens at the time only we can curtail. So, and regulation of generation of supply of electricity on account of merit order dispatch, and electricity generated from a must-run power plant may be curtailed or regulated only in the event of any technical constraint. I told you, right? So extreme technical constraints are there, then only you can curtail the RE power, stating the reasons of security. And ultra mega renewable energy parks also, it was planned, in that order. And for those ultra mega renewable energy parks, providing land and transmission for installing those RE projects also is crucial. And notification of prescribed trajectory for RE power bids it was issued by RE implementation agencies. And under the trajectory, 50 gigawatt per year is the target. RE bids should be called for. And for promoting the use of RE and replacing the costlier thermal and hydropower, like few thermal power plants are very costly, like Kudgi. Okay, so and a revised scheme for flexibility in generation that we have already discussed. What are the challenges and the schemes for the thermal and big hydropower stations through bundling with RE and storage power. It was issued by MOP also. This is about again generation flexible operation. This we have already discussed about MTL 40%. And when it comes to transmission, so establishment of REMCs are very important, like renewable energy management centers. So far because of the RE capacity. So in South we have four states we are having REMC and good compared to other regions. For smooth integration of growing RE capacity into the grid with RE forecasting and schedule tools, REMC will take care of this. This happens at a level of RLDCs, and one energy management center have been already commissioned, but planned. So in South 4 it has been planned. And green energy corridors. This is very important because when any solar project comes, and we need to whatever the evacuation and path through transmission lines and the grid connectivity, all those things that comes under this green energy corridors, that can be solar or wind, and whenever integration happens into the grid, that is also clearly mentioned when it comes to transmission. What are all the green energy corridors? And it has to happen on very fast basis. Okay, whether it can be intrastate, it can be intrastate. Infrastructure being created under this project for integration to integration of RE. And for encouraging RE capacity addition, MOP has issued so many revised orders for waiver of interstate transmission charges. You might have already heard from many news, also print media about this. So to encourage them, and not only solar, wind, green hydrogen, ammonia, and pump storage and energy storage sources, and RE evacuation also. So by construction of interstate transmission system and entailing of an outlay of so 20,700 crores for evacuation of 13 gigawatt RE from Ladakh. These all things also evacuation path. Green open access rules are also introduced in 2022, and RE integration plan, transmission system for integration of over 500 gigawatt RE capacity. So that was formulated by CEA and launched on 7th December. And obligations. So there are purchase obligations was formed in 2023. RE purchase obligations, both on generation and purchase also by DISCOMs has to purchase as a mandatory that RE, if they are not generating, they have to purchase RE from whoever is generating, and of course energy storage. So that's why many DISCOMs now calling tenders for for energy storage systems as a part of these obligations, and even so many DISCOMs also focusing or buying power from RE, or NLDC is taking care of monitoring all these purchase obligations. And trajectory of RPO is also being enhanced from 29.9%. It was in 2024-25, and we aspire to reach 43.3% by 29-30. Renewable generation obligation is there. Like although you are generating fossil related like coal, lignite, all these thermal power plants, they need to parallelly generate some portion, some percentage renewable energy also. Like if you see minimum RGO percentage on or before 31st March is 6% and 10%, and from 1st April 2023 to 31st March 2025 it is 10% minimum RGO, and from 1st April 2025 it is 10%. So these are all the due dates. Okay, now comes to RE means even green hydrogen also MOP and CA together working. We have brought up with green hydrogen policy to incentivize and encourage production of green hydrogen, green ammonia and their applications in the country. And Union Cabinet also has approved a National Green Hydrogen Mission in 2023. And market mechanism. So we didn't address this one, launch of green term ahead market. Like in the real time, we have day ahead market, And then if you are aware about market operations and grid operations as a part, market operations is one thing where real-time market and day ahead, all these markets happens. Likewise, green term ahead market is also facilitate the sale of RE power through exchanges. So green day ahead market to facilitate the trading of RE power to meet green targets also. And real-time market is anyhow there to manage RE intermittency and demand variation. So permitting foreign direct investments also up to 100% under automatic role. That is also one one of the market mechanism. Storage. So this viability gap funding for the BESS is cabinet approved this. This scheme titled viability gap funding for development of BESS. And these projects of total 4,000 MWH megawatt hour to be developed by 2031 under this scheme through competitive bidding. So that this scheme will reduce the cost of storage also. So now the storage system is very huge cost. So, then this viability gap funding scheme for offshore wind energy projects, at a total outlay of 7,453 crore, including 6,853 for installation, commissioning of 1 gigawatt of wind energy offshore wind energy in coasts of Gujarat and Tamil Nadu. So this is all about RE integration. So before I end my session, I want to talk about my organization also. So what exactly the role of CEA. So this is my organization, and it is held by chairperson with members. And this is the Electricity Act 2003, which talks about NEP. We discussed it, right? As per this section 3, NEP and tariff policy and National Electricity Plan in accordance with NEP happens once in 5 years. And section 8 talks about hydroelectric schemes, and section 53 talks about provisions relating to safety and electricity supply. And section 73 detail the functions and duties of our organization CEA. We advise central government and state governments and all the licenses like generating companies, DISCOMs generating companies. And we specify the technical standards for construction of electrical plants, electrical lines, and connectivity to the grid. And specify the safety requirements also, grid standards for O&M, operation and maintenance of transmission lines, like when to go for maintenance, when to operate, and when to keep it under shutdown for the units and transmission lines also. And conditions for installation of meters for transmission and supply of electricity. Of course, promote and assist in timely completion of schemes and projects. We monitor so many schemes and projects, and we appraise the same thing on timely basis to MOP. And collection and analytics also. Data is very important. That's how we can do the forecasting, and where we are right now, that is completely based on the data. That's where statistics and the data. So everyone is supposed to share when we ask something, and promote research as per this section 73, and R&D also, and any investigation for the purpose of power sector. These all we take care of. And section 177, this is the regulation making power of CEA to make regulations. So that can be installation and operation of meters, smart meters, all those. Grid standards, technical standards for connectivity to the grid, and measures relating to safety and electric supply, and technical standards for plants, and statistics and information. These are the regulations so far notified by CEA under Act 2003. And policies and plans also. That NEP I already addressed upon this NEP. We have already discussed NEP and what are the visions that CEA has. As per the our country growth GDP. resource adequacy plan is one thing that we closely work with states and UTs. Annual revision under progress up to 2035, and future generation anticipation, and the NEP transmission and right of way issues, anything are there. These are all the things that we work upon. So I'm proud to be part of this organization, and I once again thank AICTE and Vishnu Engineering College so for giving me this opportunity. I hope it has some you got some nuggets from this session, and anything related to so RE integration and all, you can reach out to me. However, time constraints are there, so
Yes.
definitely, so whenever again opportunity is there, so I will talk upon any topic on power sector. So thank you, and
Sure, sir.
over to us.
Yeah, thank you, sir. Thank you so much, sir. So we know that you have a very busy schedule, sir. So just as a final call, we expect we just have an announcement for the participants. If you have any question, we'll be taking over within few seconds. We request the participants, if you have any questions, please interact with our resource person. Okay, sir. Sir, I have one question, sir. A very small question. So generally, how does CEA coordinates with the state electricity board, sir? Means with respect to renewable energy, when it is connected to various forms of the grid. So for a smooth grid operation, how CEA is coordinating with the state, sir? That's what I like to know.
So actually, power is a concurrent subject. Okay, in the scheduled list, power comes under a concurrent subject of Indian Constitution. So state has their own powers and central has their own powers. Unlike railways, if you see it is monopoly, it's a central subject. But when it comes to power, it's a state subjects. But with a kind of permission based, we with the help of regulations, we coordinate at a level of RPCs. We call it regional power committees. So where state authorities, load dispatch centers, on a monthly basis, we coordinate with them on all the policies that can be operation, that can be protection, that can be commercial aspects, communication aspects. Everything we coordinate with the help of RPCs. RPCs are the subordinate offices of CEA. So I mean, so there are so many generating units are there, especially in South, and so many transmission utilities are there. So except DISCOMs, because DISCOMs have their own SCRCs. So unless they brought any issues to us, but we closely work with Transcos and Gencos.
Oh, okay, sir. Okay, sir. Got it, sir. Thank you very much, sir. So finally, thank you very much, sir, for your wonderful and informative session. You have clearly explained the important role of electricity authority in integrating renewable energy in India. We really gained valuable insights from your talk. On behalf of the management, faculty, and all participants, we sincerely thank you, sir, for sharing your knowledge and taking time to be with us today. Once again, thank you very much for accepting our invitation, sir, and sparing your time for us.
Thank you. Thank you
so
once
much,
again.
sir. Thank you so much.
Thank you.
So, dear participants, with that, we conclude the day 2 session for Atal FDP. On behalf of the organizing team, I extend sincere thanks to our eminent resource persons, Dr. Piyush Verma sir and Shri C.H. Rajesh Kumar sir, for their valuable contributions, and to all participants for their continued enthusiasm and encouragement. So tomorrow we'll be having the exciting sessions on SRM drives for EV and pumping applications, and solar PV power conditioning systems for standalone applications, which is led by Professor D. Vijayabhaskar sir. He is from IIT ISM Dhanbad, and Dr. D. Ravindra sir. Okay, sorry to say this, the same, right? Same resource person is handling 2 sessions, both session 5 and session 6 of day 3. Dr. Devara Vijayabhaskar sir, he's from IIT, ISM Dhanbad. He's also excellent academician and research. Please make use of his expertise. So, and also we request you to please join us on the sharply 6 p.m. in time to make the most of the discussions to be very smooth and ahead. And this session feedback link will be shared. Shared, sir? This link has been shared in the chat box. We request you to please submit your feedback, both MS Teams joining and also the feedback submissions. We'll be considering both as your attendance. And finally, we'll be closing the session. And thank you, everyone. Thank you, everyone. Okay, sir. Can we end the session? So thanks the participants for joining us. Have a great evening. Thank you. You can leave the meeting.